Chapter 1 quiz over lessons 1 through 4. On the back, you're going to have a Chapter 1 vocabulary quiz. These are actually going to be your review for the chapter. So you can see you have exponent here, and you can match that up to this exponent right here. And then greatest common factor, you can match up to either the greatest number of a list of common factors or the least number of a list of common multiples. And then you have least common multiple would be the other one of those. So look those up in your vocabulary and match it up. And then you have number line, which you can see which one is a number line, and you would say this one. So I'll help you out with the obvious ones, and then you do need to make sure you know the difference between those. Perfect cube would be what number times itself again would equal something. So that would be the 5 times 5 times 5. That's one example of a perfect cube. If you remember, radical is the one that looks like a division bar, but it has the extra little line on it. It's to symbolize square root, or if there was an exponent here like a 3, that would be cube root. And then order of operations would show the order that you follow to solve an expression or equation. So that would be PEMDAS, which would be parentheses, exponents, multiplication and division left to right, addition and subtraction left to right. And then don't forget to do the greatest common factor and least common multiple. And then you just need to turn it over to lesson 1, remembering that on the example here, it has the word from. And if you see from on a question, remember that would include the numbers on the ends. So that would include 3 and 9. So all of the positive whole numbers from 3 to 9 would be dotted. If it would just said odd, then you would just dot the odd. If it had said even, you would dot those. If it said between, you would not include the ends. Then we also, in lesson 1, I believe it was where we would compare numbers such as like 2 and 3/10. And you'd say whether it was greater or less than like 2 and 7/10. So then you would make that a common either fraction to this one and then compare. So you'd make it a decimal and then this one a decimal, or this one a fraction to compare to this. And then remember, on number lines, sometimes you're going to need to be able to number them by fractions as well. So you might have a number line that's spaced out and it starts like this, and you have like a 1 and a 2 here. And then you have spacing here, so you have to figure out what those are spaced by. So this would be, remember, the 0, 1, 2, 3, and then this would be 4. So that tells you your denominator. So this would be 1/4, 2/4, 3/4, and 4/4. And we're between the whole number 1 and the whole number 2. So this would be 1 and 1/4, 1 and 2/4, 1 and 3/4, and 1 and 4/4, which equals 2. And then if it had said, like, dot the mixed numbers between 1 and 2, you would dot all of the mixed numbers between 1 and 2. When some of you draw your own number lines, I see you forget to put the arrows on the ends. So make sure the arrows go on your ends. You can add it to this one if you'd like. Lesson 2 was the beginning of the prime factorization charts. Some of you liked the tree diagrams, but you should be well practiced in the prime factorization chart. So when you're looking at prime factorization of 36, you would quickly do your prime factorization, and then remembering to put your product of your composite number. So you're listing them out in order from least to greatest. So if you had divided by 3 first, you would not put the 3 first in your list. And then some of you might like to write exponents, so the answer would also be okay if you would put 36 is equal to 2 squared times 3 squared, because there's 2 2's and 2 3's. And then greatest common factor, you're just going to do prime factorization of the two numbers. And then remember, greatest common factor, you are multiplying everything that's on the left. So that was make our F from the greatest common factor word. So I can divide both of these by 2. Both of those by 2 again. Both of these by 3. And then I have to stop because I can't divide those by the same thing. So I multiply 2 times 2 times 3. So 2 times 2 is 4 times 3 is 12. So the greatest common factor of 24 and 36 is 12. And then remember, if you have a third number, you have to make a second chart, put the greatest common factor in with that, as well as the third number. Okay, least common multiple, so I can use this same work, but then the least common multiple, remember, I'm multiplying with the L. So that would be the 2, the 2, the 3, the 2, and the 3 from my work up here. So I have the 12 that I multiplied before from the 2 times 3. And then if I multiply times the 2 times the 3, that would be 6. So 12 times 6 is 72. So the least common multiple is 72. And then again, if I need to do a third number, I would just put the least common multiple in a second chart with the third number. Okay, if you have to find the greatest common factor and the least common multiple, you can use the first chart the same as with the first two numbers, but then you need to make a second chart for the greatest common factor because the greatest common factor will be different from the least common multiple. So you need to make a second chart for greatest common factor and a second chart, well, technically a third chart for the least common multiple. Then the square, if it says find the square, you're doing this number squared. So it would be 36 times 36 in solving that. If you're finding the square root of 36, that's when you do the prime factorization chart, which we already solved up here. So you would say that the square root of 36 would be equal to 6. So remember, you're looking for sets of 2. So if I was looking for sets of 2 up here, I would have highlighted the 2 and the 3. So 2 times 3 is the 6. And then you can check it. Does 6 times 6 equal 36? And the answer is yes. So the square root of 36 is 6. But for this problem, the square of 36 would be 36 times 36, and you'd find your answer. And then finally, if it says the cube of 36, that would be 36 cubed, and you would do 36 times 36 times 36. And then if it said the cube root of a number, then you would do the prime factorization again, and you'd look for sets of 3. So like if it said the cube root of 64, you'd be looking for sets of 3 with your prime factorization. And that's a quick review of chapter 1. We're going to do the chapter review. If you have any questions, of course, your teacher should be there to answer.